This is a demonstration video showing some of the chemical characteristics of sodium metal along with some of the chemical reactions of sodium and sodium-based compounds. Sodium metal is typically stored in the mineral oil, as sodium metal would react with the humidity in the atmosphere. And unlike most metals, sodium is relatively soft, so it can be cut with a scalpel, as shown here. You wouldn't be able to cut a block of iron as easily as this. When the sodium metal is cut, you can see a shiny metallic surface is exposed. The shiny surface created will rapidly tarnish in air due to the humidity, then form a dull surface. Since sodium metal is reactive, the first set of experiments we're going to perform, we're only going to use a small amount of sodium metal. The larger pieces of sodium metal we're going to store back under the mineral oil until we're going to experiment with those later. The first chemical reaction we're going to look at is sodium metal reacting with water. We measured the initial pH of the water and found it to be around 6. Now we drop in some sodium metal and immediately you can see a reaction. Once all the sodium metal is reacted, we've measured the pH of the liquid again, and this time it is alkaline, with a pH of 14. This is due to the formation of a solution of sodium hydroxide. Let's put a larger piece in and light the hydrogen. See the characteristic yellow flame of sodium? We'll try an even larger piece towards the end of the video. More sodium metal was reacted with the water to form a stronger solution of sodium hydroxide, and now we're going to have a look at some of the chemical characteristics of sodium hydroxide solution. To start with, we're going to pipette a small amount of our concentrated sodium hydroxide onto some aluminium foil, and you can see a reaction where the sodium hydroxide is reacting with the aluminium to form aluminium aluminate and hydrogen gas. In our next demonstration, we're going to see the chemical reaction between solutions of copper sulfate and concentrated sodium hydroxide. In this demonstration, concentrated sodium hydroxide solution is going to be pipetted into the blue copper sulfate solution. When these solutions meet, you can see a precipitate is formed. This is a double displacement reaction, and the precipitate formed is copper hydroxide. In the next demonstration, we're going to look at the reaction between copper nitrate solution and sodium hydroxide. In this demonstration, concentrated sodium hydroxide solution is going to be pipetted into the blue copper nitrate solution, and when these solutions meet, again we can see a precipitate is formed, and this precipitate is again copper hydroxide, and the double displacement reaction has also formed sodium nitrate, which remains in solution. In the penultimate demonstration, we're going to show the rather gruesome reaction between concentrated sodium hydroxide solution and a raw chicken drumstick. This reaction is shown by immersing a chicken drumstick in a solution or a beaker of concentrated sodium hydroxide solution at around 60 degrees Celsius. After about an hour, when we decant the solution, you can see quite gruesomely that the chicken drumstick has effectively turned into a liquid soap, and all that's left over is a chicken bone. So this illustrates the potentially dangerous nature of sodium hydroxide solution. In our final demonstrations, as promised, we're going to experiment with the larger blocks of sodium metal And to do this experiment, we ventured outside rather than to conduct this experiment within the workshop. We set the cameras up and chucked a rather large block of sodium metal into a lake of water, and after a few moments we have an upscaled reaction of what we saw in the workshop. Thanks for watching.